Hey, this is Mr. Mitchell. I'd like to talk a little bit more about compounds. We've talked a little bit about compounds, but we haven't looked at them too in depth. We had covalent bonds in compounds, and we have ionic bonds in compounds. Let's take a look at some of both. Here you have an atom of hydrogen and an atom of bromine. Hydrogen has one dot in the dot diagrams because it's in this column, and bromine has 7 because it's in this column. So it's simple as that. 1 plus 7 equals 8. And that's how you fill the outer shell. So all of these that have 1 will tend to easily bond with all those that have 7. And that's why they're the most reactive ones here. But it's not just one-on-one bonding, but it can be 2-on-1 bonding. For example, here hydrogen has 1 dot, and here sulfur has 6 dots. If you just add 6 to 1, then it's not going to be 8. But if you have 2 hydrogens, then you have 2 dots. First one, and then the second one. So that's how you can then make a total of 8. So you have 2 hydrogens and you have 1 sulfur, which make the total of 8. Now if we look over here at the top highlighted, we have the ionic charge. You remember that all of these tend to lose their electron, and that would leave them with a charge of 1. And it makes it easy for us to see what kind of bonds we will have. For example, the HB, the H is in the +1, the BR is what I should say, it's in the -1. Notice that they end up at 0, just like all these in the noble gases are 0. So they have to end up with 0 if you look at all these ionic charges. So when you have 2H and 1S, 2H is going to be +1 and +1, which is +2. Go over to the S, and that is -2. So you can see they have to balance out if they're going to be a covalent or ionic compound. Here we have nitrogen. Nitrogen, this was one of those diatomic molecules. One of these diatomic molecules, they have to bond with each other. Now that one's going to end up being -3 and -3, so the diatomics are not going to be as easily balanced out. But look what's happened here. The nitrogen has arranged the electron, and you can see it on the dot diagram. The shell can be arranged to where you have all of them piled up on one side. So you literally have 2 on one side, and these other 3 have been pushed to the middle so it can make a bond with 3 of the other nitrogens. So these diatomic ones kind of get around that, but for the most part, you're looking for the positives and the negatives. Let's take a look at these ionic bonds. Here's the simple one. Mg has 2, O has 2 spaces to fill. Over here, Mg is +2 and O is -2. Makes that one very simple. Just like NaCl has 1 space to fill. 1 dot fills in where this 7 dots cannot fill that extra one. And that way you've got NaCl. If you look over here, Na is in +1 and Cl is in -1. That makes it simple. Look at this one. Mg has 2 dots. But you have Cl, which only have 1 spot open if you have just 1 Cl. But if you have 2 Cls, like MgCl2, then both of those dots have a place to go. Now let's see what that looks like over here. Mg is going to be +2, so it has to even out. You have Cl, which is -1, but if you have 2 Cls, then you have -2. -1 plus -1. So yes, it does balance out. So you see what we're looking for in all except those diatomic molecules? Okay, so let's see what we have here. We have Na and Cl, which we said just a little while ago was 1 Na and 1 Cl. And the reason it's 1 is because Na is in the +1 and Cl is in the -1, and you can see also one dot goes in this one space. This one, however, is not going to be that way. Lithium has one dot for two spaces. So what would the formula be, the chemical formula be, when you have Li and O that bond? What do you think? Let's take a look here. Li is +1, O is -2, so you have to have two Li's. Li1 is +1, so another Li would make it +2, and that would even out. +2 and -2. Does that make sense? So that would be Li2O. What about this one? Beryllium and chlorine. It doesn't seem to fit. Beryllium just has the two dots, but chlorine only has one space right here. So if you just have one chlorine, it's not going to work. But what if you have two? That's what's going to work. Let's double check it here. Beryllium is +2, chlorine is -1. So if we have two chlorines, that makes it -2, and it works out. So we have the 2, BeCl2. This next one's a tough one, but I bet you might can figure it out. Mg has two outer shell electrons, whereas phosphorus has 1, 2, 3, 4, 5 outer shell electrons. You add them together and you make 7. That doesn't work out. But maybe you can see it a little bit better over here. Mg is +2. P is -3. What if you had 3 Mgs, that would be +6, and you had 2 Ps, that would be -6. And that's exactly how it would work out. So some compounds have more than just one atom on each of them. Mg2, oh, I said that wrong. It wouldn't be Mg2, it would be Mg3. There we are. So Mg3 and P2. So 2 P's is -6 and 3 Mg's is +6. And if you had 3 Mg's, that would be 6 dots. And if you had 2 P's, you would have 1, 2, 3 times 2, 6 open spaces. So it works out well either way. So that's kind of an introduction to how you are going to have things bond. And in class, you're going to look at lots of combinations and figure out what these chemical formulas would end up being. Look forward to seeing you in class. Bye-bye.